Okay, continuing on here. We have a radical example. We want to find the midpoint and the distance between point C at root 2 negative root 3 and point D 3 root 2 and 2 root 3. So we have to use the midpoint formula. So the midpoint formula is x1 plus x2 over 2. So that would be root 2 plus 3 root 2 over 2. And our y point would be negative root 3 plus 2 root 3 over 2. So let's do some simplifying there for the midpoint. So this would be 4 root 2 over 2. And this would be, for the y point, would be root 3 over 2. We could reduce this one x point here to simply have 2 root 2 and root 3 over 2. That is our midpoint of between those 2 points that we had, C and D. Now, if we want to find the distance, we have to use the distance formula. So that would be x1 minus x2 all squared. So x1, that would be root 2 minus negative root 3 all squared plus 3 root 2, or sorry, I got that one wrong. This is supposed to be 3 root 2 here. 3 root 2. Supposed to use the x point, not the y point there. Okay, so this is root 2, and then this is minus 3 root 2. Okay, then I go to the y point, so I erroneously started there. Negative root 3 minus, and the y point over here is 2 root 3 all squared. Okay, so we can combine these in here as well. So root 2 minus 3 root 2 is negative 2 root 2 all squared. And here we have plus negative root 3 minus 2 root 3 is negative 3 root 3 all squared. So we do the squaring in there. Okay, so negative 2 times negative 2 is 4. And root 2 times root 2 is 2 for squaring of that. Negative 3 times negative 3 is 9. And root 3 times root 3 is 3. Okay, they are all positive because when you negative and a negative gives you a positive. So here we have the root of 8 plus 27. So that would be the root of 35. And that's as reduced as it will get. So there's a couple examples there of working with a distance formula and midpoint formula in section 7.1.